So the last little bit that we have to do in the first part of chapter 8 is the dot product and the cross product. And the dot product has also been called the inner product. And as you might have guessed, it's represented by a big dot. So it doesn't mean times, it's a dot. And then cross product is represented by an X. So again, it does not mean times, but it means cross product. So the dot product, the little thing is, so if the dot product of two vectors equals 0, then they are perpendicular. Here's my little sign for perpendicular, and remember that means they meet at a right angle. So if you get another number other than 0, they're just not perpendicular. Okay, so the dot product tells you whether or not they're perpendicular. So I'm going to give vectors A and vector B. So it's pretty easy. You take the first two numbers, multiply them to the second two numbers. What does that equal? You're trying to decide if it equals 0. Negative 14 plus 14 equals 0. So this means vector A is perpendicular to vector B. Okay, and it means the same thing in 3D. When vectors are perpendicular in 3D, they make like the corner of like a Kleenex box. So if I draw my little box here, you guys know such a good artist, right? But these corners here are perpendicular to each other. Okay, so it works the same in 3D. You'll multiply the x's, the y's, and the z's and add them together to get to find out if they're perpendicular. The cross product creates a vector that is perpendicular to two given vectors. And so this one is a 3D thing. So if I give you in 3D this one and this one, you're going to create this one, the third side of my box here. It's also perpendicular. So A, I'm going to give you is 1, 2, and 3. And B, I'm going to give you as 4, 5, and 6. So then you'll see this. Find A cross B. Like this one would be A dot B. Should have written that before. This is A cross B. So linked to this is some information on how you can program your TI-83 or TI-84 calculator to give you the cross product. If you don't have that, it's going to be, you're going to have to do it by hand, which is fine. It's not too difficult. So I will show you that process. Otherwise, you may use your programmed calculator on the test. So you're going to write these on top of each other 3 times. So 1, 2, 3, 4, 5, 6. And do it again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. And then in the following order, you're going to cross off the first number, the middle numbers, the last numbers. Okay. Then you are going to take and go with what you have left, like 2 times 6, and then back this way, minus 3. So 2 times 6 minus 3 times 5. Okay, so go this way. 2 times 6, I get 12 minus 15, negative 3. That's the x portion. Okay. Next one is going to be, you're going to take this now and move it. So it's a little bit like we have to move this one over here because they have to be right next to each other. So I'm going to have 1 and 4 here. And now, again, you're going to do the same thing where you do 3 times 4 minus 1 times 6. 3 times 4 minus 1 times 6. 12 minus 6, 6. That's your y component. And then for the last one, you're going to do the same thing. You've already got them crossed out. 1 times 5 minus 2 times 4. So minus, so I get 5 minus 8, and I get negative 3. And that is my vector that is now perpendicular to both A and B. So if I graphed A and then I graphed B, I'm creating a third vector that is perpendicular. How could you check that it was perpendicular? You could do the dot product to determine if they were actually perpendicular. It would be 0. Okay, so this is the last bit, dot product and cross product. This you may use your calculator if you have one and you programmed it, and the instructions are, on this page. Otherwise, you can just do it by hand, which doesn't take that long.